In every step we take and in every second of our lives, in everything we do, forces travel to everything around us, from objects we touch to the objects we push, from objects that collide to every button that we press, from the simplest things that all of us do to the hardest things that everyone wishes they could do. Sir Isaac Newton, an English physicist and mathematician, stated that for every action there is an equal and opposite reaction. This principle is later on called Newton's third law of motion. Imagine you are working out and doing push-ups. The stronger the force you apply, the faster you go up. But believe it or not, you are only doing half the work. The force you apply is only a part of the force essential for you to go up. The question is, who does half the work? Or better yet, what? According to Newton's third law, when an object A applies a force on object B, object B will apply the exact amount of force back on object A. So when we are pushing down on the ground is pushing us up with the same amount of force that we applied to it, enabling us to do push-ups. Another way of representing Newton's third law is by using a traditional example, which is the rocket launch. When a rocket launches to space, its thrusters propel the rocket upward by applying a huge amount of force down on Earth. At the same time, Earth applies the same amount of force on the rocket, enabling it to fly up. To represent the rocket launch, we are going to do a demo using soda, a stick of Mentos, and some tape. Take approximately 5 inches of tape and stick 3 Mentos on it. Take the other end of the tape and stick it on the cap of the bottle. Last step is to shake it very well.
Actual space rockets are lifted outwards in a similar way, except those rockets use fuel containing much more energy, ready to be released. The shape of the rocket directs all the force downwards, against the ground, which makes the ground push outwards against the rocket with equal force. In our experiment, we decided to use Coke and Mentos to demonstrate Newton's third law. The rapid production of CO2 gas should knock off the cap, creating a push on the ground, making the bottle go upward. But the force exerted by the gas on the cap was too low to overcome the normal force created by the screw cap. If the ball is dropped properly against the floor, the sudden increase in pressure should be enough to overwhelm the screw cap, releasing all the pressure almost instantaneously.